Assalamualaikum and hi to everyone. Thank you for watching this video. So in this video, we continue on the Deadlock chapter, part 3. Okay, in the previous part, we already looked on the method of handling, prevention and the avoidance. Okay, you can refer to this method for handling the deadlock. We have deadlock prevention, deadlock avoidance, detection and recovery from the deadlock. So the previous video, we already looked at the example of the banker algorithm. Okay, so we in this part you should know how to calculate the needs based on the maximum minus the allocation. So we continue on the another method, which is deadlock detection. So this method is quite different compared to the previous method, because in the previous method we try to avoid, we don't want the deadlock occur in our system, but in this method it's allow the deadlock to exist, and then use the algorithm in order to detect the deadlocks and try to terminate the process one by one. Okay, so look at here. So the deadlock detection allow the system to enter the deadlock state. So this is the difference between the deadlock detection and the deadlock avoidance and prevention. So we have the detection algorithm in order to detect the deadlock, and then after we detect, we have the recovery scheme. Okay, single instant of each resource type. So let's say we have single instant in our resource. So we have maintain wait for graph, and known are processes PI, PJ. Okay, we have PI, we have PJ. So if PI is waiting for PJ, so it's look like this one. So that means PI is waiting for process J. Process I is waiting for process J. Okay, later on we'll look at the wait for graph. Okay, so this wait for graph is the type. Before this, we learn about the allocation graph. Resource allocation graph. So in the previous graph, we have processes and we have the process and we have the resources. In wait for graph, we only have the processes. So predictly involve an algorithm that search for a cycle in the graph. So basically, the algorithm will search the cycle in the graph. So that means if the cycle exists, means that the deadlock happened, because we want to detect the deadlock. Okay, that's why the algorithm to identify the circular or the cycle inside the graph. So an algorithm to detect the cycle in a graph require an order of n square operations. N is referred to the number of vertices in the graph. So it's like this one. We have two types of graph. This one is the previous video. We already looked at the resource allocation graph. So we have the resources and we have the process. So a square here without a small square. So we can assume that the resource only has one instance. Yeah, otherwise it will draw multiple instances inside the resource. So this is resource allocation graph, where we have the processes and we also have the resource. Process make a request to the resource. Resource is belong to process. Okay, you should know how to read the resource allocation graph. And this one is the wait for graph. In the wait for graph, we only have the processes. So we try to detect the cycle inside the graph. For example, here, how to read it? PI is waiting for PJ. So process I is waiting for process J. So in this part, process 1 is waiting for process 2. Process 2 is waiting for process 3 and process 5. Process 3 is waiting for process 4. Process 4 is waiting for process 1. So you look at here, it is a cycle. So we want to detect the cycle in this wait for graph. So there are three terms that you should know: the available, allocation, and request. Okay, quite similar like the prevention and avoidance. We have the allocation, request, maximum, needs. Okay. So available is referred to the vector of the length m indicate the number of available resources of each type. Okay, the available resources. Allocation and n times m metric define the number of resources of each type that currently allocated to each processes. Means the resources that allocate to process. And then we have the request, and n times and n times m metric indicates the current request. So the current request of each process. So if the request ij, okay, this one is the metric ij equal to k, then the process I is requesting k more instances of resources type in resource G. So I here refer to the process, J here is referred to the resource. So this is the algorithm for detection. So let's work and finish be vectors of m and n. So we have work and finish refer to the m and n. So work equal to the available part. Okay. For I equal to 1, 2, 3 until n numbers. If allocation not equal to 0, then finish I refer to this number equal to false. Otherwise, finish I equal to true. So this is the Boolean statement, either false or true. And step number 1 here, the initialization. So next, step 2, find an index I such that both. Okay, you need to find index I, finish I equal to false, or request I equal or lesser than work. Means refer to the available allocation part. So if no such I exists, this one, so we go to step number 4. Step number 4, if finish I equal to false, or some I 1 lesser or equal to I, or I lesser than equal to n, then the system is in deadlock state. This one to detect the deadlock. Okay, moreover, if finish I equal false, then process I is deadlock. So we need to identify which process is a deadlock. Okay, for step number 4. Okay, step number 3, if work equal to work plus allocation, so finish I equal to true, go to step number 2. So step number 4 to detect the deadlock. Okay, algorithm require an order of O, M times N square operations. This one is operation, detects whether the system is in deadlock state. So basically this is step 1, step 2, step 3 and step 4 is the algorithm that we use in order to detect the deadlock. So example of detection algorithm. Okay, let's say we have 5 process 0 until process 4. And we have 3 resources type A, B, C. So A, we have 7 instances. B, we have 2 instances. And C, we have 6 instances. Instances inside the resources. Okay, so snapshot at time 0. Okay, at time 0, we have allocation, request, and available. So this one is based on what we already discussed in this part. Okay, available, allocation, and request. So we have allocation, request, and available for resource A, B, and C. So for process 0, 0 from A, 1 from B, 0 from C. So this is the allocation. We allocate 1 from resource B. Okay, P0 does not make any request for process A, B, and C, and the available is 0, 0, 0. So for process 1, process 0. Okay, next we go for process 1. Okay, allocation 2 from A, 0 from B, 0 from C. So P1 may request 2 from A, 0 from B, 2 from C. For process 2, the allocation is 3 from A, 0 from B, and 3 from C. Okay. For request, 0 from A, 0 from B, and 0 from C. For process number 3, 2 from A, 1 from B, 1 from C, and request 1 from A, 0 from B and C. For process number 4, the allocation is 0 for A and B, and 2 for C from C, and then the request is 0 from A and B, and 2 from C. So this one is the allocation. Okay, you know that the instances is 7. When you total up, you get 2 plus 3 equal to 5, 5 plus 2 equal to 7. So 7 instances. Okay, for all the process at time 0. For B, 1 plus 1 equal to 2, 2 instances. For C, we have 3 plus 1, 4, 4 plus 2, 6. 6 instances. The allocation for each processes. So the sequence here, we have P0, okay, P0, and then P2, P0, P2, and then P3, 0, P2, P3, P1, and P4. So based on this sequence, P0, 2, 0, 2, 3, 1, 4, this will result in finish I equal to true for all I. Okay, refer to this part, this algorithm. Okay, so P2 requires an additional instance of type C. So request 1, this one is 0. Okay, this one is request an additional instances. Okay, you need to identify state of the system. Can reclaim resource by held process 0, but insufficient resources to fulfill the other processes requests. Okay, the deadlock exists consisting of process 1, 2, 3, and 4. So later on, we'll look more on this part. Okay, the usage of the detection algorithm. Okay, when and how often to invoke depends on how often a deadlock is likely to occur and how many processes will need to be rolled back, one for each disjoint cycle. So this one, how many processes need to roll back is the answer is 1 for each time. So let's say we have 4 processes that match similar. When we roll back one, we need to roll back one process at each time to disjoin the cycle, to make sure that the cycle is not more a cycle. The cycle is not a cycle anymore. Okay. So if the detection algorithm is invoked arbitrarily, there may be many cycles in the resource graph, and so we would not be able to tell which of the many deadlock processes caused the deadlock. Yeah, so for the recovery scheme, okay, we detect the deadlock. So how to recovery? We need the process or the method in handling the deadlock. We try to terminate the process. So abort all the deadlock processes. Abort one process at a time until the deadlock cycle is eliminated. Means that in recovery from deadlock, we need to go one to one, one by one, because we want to eliminate or disjoin the cycle. So in which order should we choose to abort? How the process of choosing which one we want to abort means the process. So it's based on the priority of the process. So these are the characteristics or the criteria that we can use. how long process has computed and how much longer to complete. Number 3, resources the process has used. Number 4, resources process need to complete. Number 5, how many processes will need to be terminated. And number 6, is a process interactive or batch. So this is how we can choose which process should be terminated. Okay, recovery from the deadlock. We need to selecting a victim. Okay, in this part, we need to minimize the cost and roll back, return the some safe state and restart the process for that state. And starvation, some process may always be picked as the victim. Okay, we have the process deadlock, so we try to find the victim. Okay, starvation here, the same process. Okay, let's say you have process 1, process 2, process 3, and process 4. So you take process 1, roll back or terminate process 1. And then when you run again, maybe the same process will be selected. Okay, the next part we will go for the tutorial. So, and for the part 3 of our deadlock handling mechanism, this one is for the detection algorithm. Okay, that's all. Thank you, and we'll continue on the tutorial for the next video. Assalamualaikum.